writing habits of Pierre the Fermat, our protagonist of this short film, have not resulted in the fatal destruction of the humankind in this universe, nor broken the time-space equilibrium in this society, but have successfully managed to rattle the sharpest brains of the creme de la creme of mathematics academia across the globe for more than 350 years. Needless to say, to do this, our protagonist not only had to be a genius, but a prolific prankster and man with an innate sense of confidence in his mathematical experience, but also somehow had a God-gifted curse of dying at moments when the world needed him most.
Fermat is talking with his understudy in his study room. They were brainstorming about the possible outcomes of the versions of the infamous Pythagorean theorem.
Say what reset? Take this equation x to the power n plus y to the power n equal to z to the power n.
What about it, sir?
Now for n equal to 1, we have infinite number of solutions.
Of course.
Also, for n equal to 2, we have infinite number of solutions by Pythagoras theorem.
Absolutely.
But that's it. I don't think it can go any further. For any n greater than 2, it will fail to generate possible solutions of the equation.
Oh, interesting.
Not only that, in fact, I might have a proof in my mind.
Fermat wrote down the following in the margin of his diary that same night.
It is impossible to separate a cube into 2, or a fourth power into 2 fourth powers, or in general, any power higher than the 7 into 2 like powers. I have discovered a truly marvelous proof of this, for which this margin is too narrow to contain.
He went to peaceful slumber after this and didn't think of it much. Some mathematicians were inquiring around some old books of Fermat. One of them finds a copy of Arithmetica, a book written by Diophantus in 3rd century AD. On the margin on one of them is scribbled this handwritten theorem. It is impossible to separate a cube into 2 cubes, or a fourth power into 2 fourth powers, or in general any power higher than the second into 2 like powers. I have discovered a truly marvelous proof of this, which this margin is too narrow to contain.
Take a look at this.
Well, the proof must be somewhere. Do we notify others of it so they can investigate reading this?
There are slim chances of finding it anyway. He probably had hundreds of these. If he had found the proof, wouldn't he publish it?
It's one small step for man, one giant leap for mankind.
x to the power n plus y to the power n equals to z to the power n. If n is more than 2, then finding possible solutions of x, y and z is impossible. It's Fermat's last theorem. He had proved it to be true for when n is a non-prime number. When n is prime, the outcomes are still unproven. Anyone who succeeds in proving it, his name will be engraved in history of mathematics forever.
Sir, we have split the atom, touched the moon. There is no such thing we can't do with modern technology. Can't we input numbers in the computer starting from 1 until we find a combination which suffices this theorem?
Well, let's say we start doing that. When do you think our quest is going to stop? If we input a billion combinations, we are left with an infinite more options to try. If we try a trillion more, we are still left with infinite options we can possibly input. Do you think this is a feasible solution to the problem? Not so much, in my opinion.
In the last clip, did you notice Homer Simpson writing an equation on the board? The episode aired in 1998 shows Simpson writing an example on how he had almost found a possible answer for the Fermat's equation.
While he seems to be at triumph, Homer's solution is what mathematicians call a near miss. It doesn't quite work. The equation aired 3 years after Andrew Wiles from England had proved the unprovable. He proved Fermat's last theorem.
The first 7 years I'd worked on this problem, I loved every minute of it. However hard it had been, there'd been setbacks often, there'd been things that had seemed insurmountable, but it was a kind of private and very personal battle I was engaged in.
Wiles states that
In September,
he came across Fermat's last theorem on his way home from school when he was just 10 years old. He stopped at his local library where he found a book about the theorem.
Exactly
Fascinated by the existence of a theorem that was so easy to state that he, at 10 years old, could understand it, he decided to be the first person to prove it.
That it really couldn't be made to work. At the beginning of September, I was sitting here at this desk when suddenly, totally unexpectedly, I had this incredible revelation. It was the most important moment of my working life. It was so. I had this very rare privilege of being able to pursue in my adult life what had been my childhood dream. I know it's a rare privilege, but if one can do this, it's more rewarding than anything I can imagine.
The first successful proof was released in 1994 by him and was formally published in 1995. It was described as a stunning advance in the citation of Wiles' Abel Prize Award in 2016. He was appointed Knight Commander of the Order of the British Empire in 2000, and in 2018 he was appointed as the first Regius Professor of Mathematics at Oxford.